Welcome to lesson 1A, which is in chapter 1. It's discussing statistics, data, and statistical A thinking. I would like to tell you something really valuable. There is a free TI-84 calculator online. You can use that, but the problem is that you cannot use this in the test, because that means you have to use the internet. We cannot use the internet during the test. We can use it during class or at home for practice. But this one is free of charge. Okay? Yeah, you will get the file. I will send you the file on Blackboard, the link. You can just open it at home. Okay? If you need to know how to use the TI-84, this link is show tutorial, how to use it. Okay? It's only one, like maybe 10 minutes or something like that. So it doesn't cover everything, just the basics. Okay. As always, you need to bring to this class few things: pen, pencil, pen or pencils. It doesn't. I would prefer pencil. Okay. You need a notebook. And instead of the notebook, you can bring the worksheet. This one, you can print it out at home. So every time you come, bring the worksheet with you, because my lessons goes like this: 1A, 1B, 2A, 2B, 3, 4, 5, 6, 7, 8, and so on. Yes, I can show you how it looks like.
So it's 2 lessons per chapter?
It's not necessary to be lessons, 2 lessons per chapter. It could be 2 lessons per chapter, or could be 1 lesson per chapter. So take a look at the lessons here. See, lesson 1A. This is lesson what? 9. Very good. Okay, and this is lesson. Very good. 14. 15 what? A. Okay, and 15 B. So whenever I have a lesson that I need to add something to it, then I split them. I say 15A, 15B, 15C.
So that's why you need the print.
So you need to print it out as a hard copy, or you do it on the PDF. A PDF on the iPad.
Yeah.
Okay. Here, listen what? 16. And it goes like this. And I give you study guides for the test.
So it's like shortcut.
Okay. So this is how it goes, how I plan my lessons. Okay. So right now we're gonna work on chapter 1, lesson 1A. Okay. So remember, we need a laptop. Of course, at home you can use your laptop or desktop. Okay. But in the class you need laptop. Also, you need a calculator, TI-84. Now let's take a look at the objectives for this lesson. Who can read the objectives? Yellow. Read 2. Each one of you read 2 objectives.
Learning objectives: students will be able to define statistics, science of statistics, and list some ways to collect data.
Very good. So we need to define statistics. What's the meaning of statistics? So you cannot graduate from this course unless you understand what's the meaning of statistics or define it. Okay. And we need to list some ways to collect what? Data. How can we collect the data? Of course, right? There must be some ways to collect data. Okay, go ahead.
List some ways to organize the data.
Yeah. So after you collect the data, what do you do with it?
We organize it.
You organize it. That makes sense. Okay.
And list some ways to analyze data, means median, mode, or range.
So such as mean, median, mode, or range. We can analyze the data this way. Okay. Okay. Yellow. Next one, please. Your turn.
Define the meaning of interpreting data. Make a dot plot graph.
So we need, what's mean interpreting data?
Putting the data into words.
Yes. And what should we do with dot plot? It's like a graph. We can graph the data using what type of graph? Dot plot. Yes.
Process.
Right. It's like dots and dots. Okay. Yalla, next one, please.
Identify what clusters, peaks, or gaps. List types of statistical applications.
So we need to define what is cluster, what is peaks, what is gaps. Second, we're gonna what list type of statistical application. Yani application, software application. Software application. Okay, is this clear?
Yes.
All right. Like SAS, so many software for statistics. Next.
Describe the fundamental elements of statistics. List types of data.
So we're going to describe the fundamental. What's a fundamental means الأساسيات صح؟ البasics. Okay. Elements of statistics. And then we're going to list types of what data. We have different types of data. We have qualitative, we have quantitative. Okay. Next, your turn.
List ways to collect data.
Yeah, how can we collect the data? Next.
Identify the role of statistics in critical thinking and ethics.
Very good. We're going to identify the role. Okay. So up to here is clear.
What's the last list ways to collect data, and the second one is I think similar or what?
List ways to collect data. Yes, absolutely right. So I think we better keep one only. Okay. So list some ways to collect data. It's the same thing, right? Yeah. Okay. Remember, this is my own work. It's not.
I know.
I try to do my best. Okay. Now, for each lesson there is a vocabulary. You need to find the meaning of those words in class or before you come to class. So here I have words, for example, mean. But how can I get these words? Online. So you can either use the book or internet to get the answer. Did you take the course of this before? No, first time. So use a book or the internet to get the meaning of the following words. Is this clear? So first word is called mean, second median, mode, range, cluster, peaks, gasp, distribution, tendency. I will give you take 3-4 minutes. Try to find a few words on your own. You have your mobile, you have your iPad, you have your computer. Try to find some words, okay?
Oh, this for chapter 1 only.
Using AI, it's okay.
Doesn't matter.
Professor, would you like the definition in statistics, or would you like just the general definition?
General, but it has to do related to mathematics. Because if I write down mean in normal English, it's give you different meaning. But mean in mathematics, well, is like an average. So mean, if you look for it, is going to be what? Average. So what does it mean?
You want the word for median?
Say again.
You want the word for,
Yeah, try to find a few words like mean, average, median, mode, range.
like, would you like us to answer, give out loud answers or just
Yeah, if you want, no problem. You finish with the first one?
second?
Second one? Okay, you want to say what's median mean?
Sure. It's the middle number in a sort of list of numbers.
Can you down?
Okay. Anybody else want to share his knowledge? So median is a middle number in a list of data, but the numbers has to be in order. The number has to be placed in order. Anybody has meaning?
Medium? Medium?
Yeah. Okay, I'm gonna leave this for you to do it later. Okay. Here we're gonna go to the notes. To learn how to create a dot plot, you can see here I give you step-by-step solution, and there is a link. You can go and watch the video to show you how to do the dot plot. Okay. Also, you can use Desmos to do the graph. Okay. A question that comes here: what are the 7 units of measurements? Anybody can tell me?
7 units.
Yes, 7 units of measurement. The answer is what? It can be length, like meter, miles. That's one way, correct? What's another way to do it?
Time.
Time. How can you measure time?
Second.
Second, what else?
Hours.
Minutes, hours, right? Days,
Years.
years, months. Okay, another type of measurement. Amount of substance. Okay. What about electric current? What do you use electric current? Ampere, volts, right? Watts.
Watt.
Also, we have what?
Temperature.
How can we measure temperature with what?
Kelvin, Celsius, Fahrenheit.
Right. Okay. What about mass? How we measure mass?
Kilogram, pound.
Kilogram, right? Pound, right? So I'll move on to the next one. Now we're going to go for definition, the difference between mathematics and statistics. Okay? The science of numbers and their operation. So now I'm talking about mathematics, like addition, subtraction, multiplication, etc. Okay? Interrelationship, combination, generalization, and abstraction of space, configuration and their structure, measurement, transformation, and generalization. Some branches of mathematics are algebra, arithmetics, calculus, geometry, trigonometry, and statistics. That's what we are doing. So statistics is a branch of what? Of mathematics. Is this clear?
Yes.
Clear or not clear?
Clear.
Clear. If mathematics is a branch of statistics. So what is statistics? I need someone to read. What is statistics?
The science of conducting students to
Studies.
studies. Sorry.
organize,
summarize, analyze, and draw conclusion from data.
So what are the steps that you have to do? What's the first step? Collect. Second, organize. Third, analyze. Summarize. And then analyze, then make a conclusion. So that's what means statistics. You have to memorize this. Okay? You cannot graduate from statistics unless you understand the definition of statistics.
Can we rephrase?
Yeah, you can rephrase. In fact, if you look on the internet or in the book, there are different definitions and hundreds of definitions. Okay? Similar. So now you try. Show step-by-step solution or real-life exercise. But here I'm going to ask you to define mathematics and statistics in your own words. So you have to write it in your own words. Okay? Okay. Now, explain steps in definition of statistics. The first is to do what? To collect data. How can I collect data? We have two ways to collect data. Either primary data or secondary data. So the first type is primary. The second type is what? Secondary. Type primary, that means you yourself collect the data type. What means secondary data? Means you go to somebody else. Sometimes they call it third party. Did you hear about something say third party? Yeah, he's collecting the data for you. Magazine or newspaper, or you go to the government if they will allow you, because sometimes they don't allow you. It's like secrets.
Yeah.
Right? So that's the ways of collecting data. Okay? Either primary or secondary. Okay? Now, the second type, what we're going to do now? The second, what we're going to do? We're going to organize. The first, we collect, correct? That's the first thing. We collect. Second, we're going to do what? Organize the data. Type, how can I organize the data? I can put the data from what? In order. What type of order? Ascending order or descending order, from the high to the, from least to highest, or the opposite, from highest to least. Also, you can put them in what? Table. Also, you can graph them. Okay. Third, what's the third step? Summarize. How can I summarize the data?
Median, and mode.
What else can I do?
Range, variation, and standard.
Now, who can remember those? Who can remember? So how can I summarize the data?
Mean, median, mode, range, variation, and standard
Deviation. Is this clear?
Yes.
So there are many ways we can summarize the data. There are other ways as well. We will learn other ways beside those. Okay. Next step, what we're going to do, the next step?
Next, we
Interpret it. That means what? We're going to answer the question, what does it tell us? What the data tell us? Okay. Last and final step, what we're going to do? Write your conclusion. Make your conclusion. Is this clear?
Yes.
All right. I try to make it as much as simple regarding statistics. What is the meaning of statistics, and what are the steps that has been done in statistics? Okay. Those are the steps.
Yeah.
What are the steps again?
Steps.
Collect, organize, summarize, interpret, and write your own conclusion. Okay. what, okay, these are the, so you see, if you take a look at other books, they write in different ways. Okay, here they say define the problem. What are the steps for statistical work? Okay, what they say, define the problem first. You have to define it, right? Define the problem, right? After you define the problem, you write what? Statistical question. Design the tools for your research. What tools you're going to be using. What else? Collect the data. Okay, good. What else you're going to do?
Analyze.
Okay, analyze the data. And what else? Make the conclusion. Is this clear?
Yes.
Yeah, but first you define the problem. Then you're going to write what? And then
design.
the tools, what you're going to use. Okay. What is a good statistical question here? You remember that I wrote this question? How can you know if the question is good for statistic? How do I know? What's a good statistical question? A good statistical question is where you expect to get a variety of answers.
Okay.
A really big range or a range of variety of answers. Means, I should say,
Many answers.
what is the height of yours, you know? So if I ask you what's your height, you're going to say 180.
180.
If I say what's your height, you say 185. Say what's your height? 187. What's your height? So I'm getting a variety of answers. You understand what I'm saying? So you try to make your question that it's not specifically for you, it's for everybody else. I can ask the question to anyone. Okay? What's the difference between survey question and statistical question?
Survey.
Yeah. The statistical question, what is the weight of freshman students in BMU? What is the height of freshman students in BMU? Type a survey question. How much do you weight? So you see the difference between this one and this one? This is more general. The one at the top is more general. This is more specific. Is this clear or not clear?
Yes.
Yeah, but this one is it's like a general. But this one is more specific. Remember, both of them, they measure the same thing, right? We measure the weight.
But in general, we should to bring the question. Bring the answer.
Yeah, what is the weight of freshman students in BMU? Means I'm gonna get your weight, his weight, and then divide by the number, and I will say, oh, freshman students in BMU, their average weight is
Similar to the grade.
like 100.
Similar to grade.
Yeah. If you GPA, for example, I can do the GPA for all freshmen or the GPA for seniors. Okay. Okay. Now let's take an example. Here, use the dot plot with a cluster, peaks, gaps to find the answer to the following table. He's giving you a table, a weight. Okay. So what's the first step I have to do? First, you have to count the number of data given. That's the first step. Is this clear? Okay, but that's our first step, to count the number of data given. How many given here? 20. Second, we're going to do what? Organize the data in order. Third, after you organize it, you have to make sure that you're right. So what should I do? Count it again. You still have 20. Number 4, grab the dot plot. That's the one that you were telling us about, the dots, right? So how many 18? 2, right? So you put 2 dots. How many 19? 3. Okay, and this is how you graph it. Next, we need to identify any cluster peaks or gaps. Now, where is the cluster? Cluster is where the data is concentrated, right? So here it's between what and what?
1921.
On 18 to 20, 23. And here we have what? What do we have here? A gap. And what is the peak? 20. Very good. Is this clear? يبقى عندك the peak, عندك the gap, and عندك you have the cluster. The cluster here is between what? 20.
18 and 23.
Yeah, between 18 and 23. The cluster is the highest points. Actually, in fact, it said around. I can change this and I can say the cluster is between what? Cluster يعني they are together. They are coming together. Okay, like for example, if I say, can you tell me where is the cluster in this class? On here, right? This area, there's a cluster, and there is another cluster here, and there is a gap in the middle. So where they are condensed. Condensed means what? متجمعين. They are joined. Okay. So I can say between what? Between 18 and 2 to 20, 23. Or I can say it's around what? Around 20. So you can write this way or that way. Okay. So we learn now the words, right? Cluster, peaks, gaps. And what else we learn? Peaks lower the highest points, right? And the gaps empty. And the cluster التجمع. Together, they are coming together. Okay. So answer the first question. Most mice weigh about how many grams? 20. How did I know it's 20? The peak. How many? We have 1 mouse, 2 mouse, 3 mouse, 4 mouse, 5 mouse, 6 mouse. 6 mouses, they are 20 grams. That's their weight. Okay. Our cluster was around what? 20. Our peaks was at what? 20. Our gaps is between what? We don't have any mouse that weighs between 23 and 27. Okay. How much does the mouse weight? Most mice weight around what? 20 grams. Okay. So that's how we would answer that question. This is the method. Variable here is what? What is the variable here?
Wait.
The weight of the mouse, of course. Okay. Now it's your turn now. Can you do this now? Look at the age of human, right?
Yeah.
And answer A, B, C. Do you have a piece of paper? You don't have. You have paper. You don't. If you need paper, I have paper.
We make lines like.
Yeah, you can make lines and you can write down. If you need paper, please come and take paper.
We need a pen as well.
Need pen too?
There's a pen here.
Okay, take.
Can I take?
Yes.
Thank you.
So how many? What are the ages here? What's the first thing you should do?
56.
You need to organize this data. Put it in order first, from low to high. And after this, ask the question. What's the question? What's the question here?
How old are people who retired early?
Very good. That's the question. See? Is this a statistical question?
Yeah.
Yes. Why?
Because it's in general, I think.
You can get a variety of answers.
Variety of answers.
Right. So write this down because I get variety of answers.
Yes.
Okay.
Yeah.
Display the data in a dot plot. Identify cluster, peaks, for gaps in the data. Can you do this graph? Yalla, do it. I will stop the recording for a few minutes and then we come back to it. Okay, so after you organize the data, you need to find the minimum and the maximum.
Yeah.
And most of the people who retire early were about
61.
60.
our cluster was around,
Our cluster,
yeah.
60.
You get this data from where? From the dot plot. So you have to
56
graph it.
to
Our peak was at how many 64 do we have? Only one.
Only one, no, 60.
So how many 60 do we have? Five. يبقى البيك 60. What's the gap? So you have to graph it. If you don't graph it, then you don't see the gap.
Yeah, yeah.
Okay, so you can have two gaps, remember. Okay, what's the variable? Age in years, right? That's the answer. Clear? Did you do that? Move on.
Where is the gaps?
You have to graph it so you can see.
Between 62.
I don't have a graph here, so you have to graph it yourself.
I got it.
Yeah. And finally, it said answer to the question. What is the answer to the question?
Most people retire early at age 60.
Most people retire early at the age of what? 60. That's how you write it down. Any other questions?
Yes, the gaps. It's between 62 to 64. Is that right or not?
You have to graph it.
I got it.
Yeah. So yeah, the gap. Okay. Now
I didn't understand the variable.
the variable. What's the variable here?
Age, you mean?
The age,
Uh,
because that's what we're looking for. The age.
I just want to make sure. Sorry, my glasses. It's the more longer here from 56 to 60, so the closer from here, yeah, it comes.
Okay, when you do
The gap.
the graph, you have to start with a number. Like say, for example, you start from 50.
50.
Okay.
Ah,
First number is going to be 51, right?
yes.
So 50, 51, 52, 53, 54, 55, 56, 57, 58, okay, 59, 60, 61, 62. I'm going by one. I'm counting by one, but you can count by two. I can start with 50, then next number is going to be 52, then 54, then 56, then 58, then 60.
Until I reach
It
that.
depends on the numbers you have. Okay?
Yeah.
So, up to here is clear?
Yes.
Any questions?
No.
Okay.
I have a question.
Yes.
There's okay, let's say there's 62 and 64, but there's no 63. Do we write the gap as between 62 and 64, or do you just write 63?
Between something and something.
Okay.
Okay, like that. For example, take a look at this one. The question comes here: how many students are in my class? How many students? This is what the dot plot shows, the height of what? Of freshmen in Mr. Nader math class. Can you tell me how many students here? And how do you know? Yes.
Is it between 150 there? The highest number of students? are
No,
between-
how many students? How many students?
Oh,
How many?
22.
How many?
22.
How did you know it's 22?
I just counted the dots.
Yes, you count the dots. 1, 2, 3, 4, 5, 6, 7. Yeah, I know it's written there, but how can I figure out it's 22?
Yeah.
You count the dots.
Yeah.
Each students represent a dot. Okay. How can you collect this data well to figure out the height?
Ask each student.
Maybe the line.
You use the dots.
So you have to you can ask the students, but they have to give you a reliable answer. Or another way to do it, you measure each student. You bring a tape, meter tape, and then you measure the height. Okay. All right. Write statistical question. You can answer using the dot plot and then answer that question. What's the question will be?
How tall are the students in Mr. Nadir's class?
Right. How tall are PMU freshmen in Mr. Nader math class?
If it's not, we are not freshmen.
You can change it. You can make it senior,
Senior, okay.
junior.
Yeah.
Okay.
I mean, there is even, we can like calculate the student who is not freshman, who is sophomore.
Or you can say in general, what is height of students in BMU? And then you have to go back, measure. You cannot really measure everybody in BMU. You have to take a sample. So you come 8 o'clock in the morning and you take a sample. Come at 10 o'clock and take a sample. Come at 2 o'clock and take a sample. Come at 4 o'clock, take a sample. 5 o'clock sample. 7 p.m. sample. 10 p.m. sample. And then you collect all the samples and you generalize this to everybody in BMU because you cannot measure everybody, right? You have 3,000, 4,000 students. You cannot measure all of them. Another question: what are the peaks in Mr. Nader math class?
156 and
156 and 157. Can it be two peaks?
Yes.
Yes, it can be. So most of the freshmen are probably about 156 centimeter tall. About means round. Okay. Another one here. Can you do this? Yalla, do it. Yalla, do it on the paper.
It's already the line, the bullet area.
Yeah, how many students ran in the race? There is what the dot plot shows the time of 6th grade students in a 100-meter race. They were running. So how many students? 20. Okay. How can you collect the data?
You time it.
Right, stopwatch, right? What else?
What are
Meters, stopwatch, scale, okay. How can you, what are the units?
Seconds.
Meter, hours, gallons, liter, which one?
Seconds.
Seconds. Write a statistical question that you can answer using the dot plot, then answer the question. So what would be the question?
What were the times the 100-meter race for the 6th grade students?
Right.
How fast can the 6th grade students run a 100-meter race?
Is this a good question? How fast?
What were the times of the 6th grade students in the 100-meter race?
Yeah. or you can say what is the average, the mean of the 6th grade students in 100-meter race. Okay.
Can you say what was the time that most students finished in?
Most time?
Yeah, no,
No, we're looking for a statistical question, not a survey question. Statistical. Statistical is more general. You can get different answers, right?
Well, it can be phrased in multiple ways, correct? As long as it's a general question that receives a variety of answers.
Right. Okay. So as you can see here, most 6th grader students completed the race in what?
13.8 seconds.
13.8 seconds. Our cluster was around
13.2 to 13.9.
around what?
13.6 to 13.9.
Or we can say what?
Usually around the
13.8.
peak.
About. See? Around. What is around here? The word around here. So we say 13.8.
So the answer of around is usually around the peak.
Yes. So it's going to be here 13.8 and here 13.8. Same thing, right? Or you can say between what? 13.6
13.9.
and 13.9. Our peak at what?
13.8.
13.8. Our gaps between what?
13.0,
13.2.
13.2.
Our variable
Time.
time. So how long does it take 6th grade students to finish a 100-meter race? That's the question, you see? That's a good question, right?
Yeah.
And the answer, most 6th grader students will finish the 100-meter race in about what?
13.8
seconds.
See the answer? See the question? See the answer? Okay.
Can I see the question?
Okay. Now I'm going to give you a sheet of paper which has some numbers. And then I'm going to ask you the question, what can you do with those numbers? Okay. Can you just read it? Now, numbers means what? What type of data is this? Quantitative data. Sometimes you call it quantity. Sometimes you call it numbers. So data here here is about what? Numerical variables. How many, how much, or how often, right? So what to do with those numbers? How can you represent them? Write it back from your mind. From what we learned from the beginning of the lesson to now. I give you some, some ways to measure data. Do you remember those data? Do you remember those variables that I told you? Yeah, try to think. You can work together.
Do we really need to make a plot of
Discuss it together, please. Don't ask me, okay? So what to do with those numbers? Those numbers are numericals, huh?
Yeah.
So we're gonna put them in order, ascending order or descending order. After you put it descending order or ascending order, you find a mean, median, mode, standard deviation, variance, okay, skewness, standard error, range, minimum, maximum, sum, and count. Count means then how many numbers, right?
What's kurtosis?
It's another ways of getting solution value, okay? If you want to learn this, we'll learn it later, okay? Okay, how can I represent the graph, those numbers? I can represent them graphically. I can use what? I can use what? And other ways to graph it. Is this clear? Huh? By graph, you can use that, okay? Okay, now let's take a small example. Here are some numbers: 1, 1, 1, 10, 10, 11, 11. What's the count here? 7. Count means what? What's the range?
10.
How did they get the range? The difference between what? The highs and the lows. The mode. How can I get the mode?
Most common number.
Most common number, right? How can I get the median? Very good. How can I get the mean? Average. How can I get the max? Largest number. How I get the min? Easy as easy?
The mean كيف 6
Average.
average كيف
You add all the numbers and divide by the total numbers. What's the total numbers? 7. So 1 plus 1 plus 1, 3. 3 plus 20? 23 plus 22? How much? 54. Divide by 7? How much? 6.42. Now, can you do this now? You have the paper, right? You can turn the paper to the other side and then find the answer to this one. So, starting from next class, you need to print out this worksheet so you can.
So which is it? Like which worksheet do we need to print? All of them that you just took so far, or the new ones?
Yes, the old one and the new one. So I have here. Yeah.
Sorry about that. Is it categorized like in what we're gonna have next week plus this week? Like if I go on that one, like is there like a list or what?
Here I have 1, 1, 1, 10, 10, 11, 11, 12, 12. Remember, those are different, right?
Yeah.
There is 12, there is no 12. Here I add 12. Can you find the answer to this?
Yeah, 9.
You need the count.
9.
So write the answer here.
Range.
What's the count?
9.
9. Yalla, continue. The range, how can I find the range? 11. Can you find the mode?
1.
1. Can you find the median? 10. The median is 10. Are you sure?
How come the range 11?
12 minus 1. 12 minus 1. The mean. How can I get the mean? How you get the max, min, max, min?
12 and the minimum is 1.
Finish? All right, so we are done. Now, I didn't print this out, okay? Bad me, right? Now, this numbers is called quantitative. Not quantitative, it's qualitative. Qualitative means what?
Words.
Words or categories. Take a look here. Data are measures of times and may be represented by name, symbol, or number code. يبقى name, symbol, number code. What do you do with those names? How can we represent them? Numerically or graphically? Huh?
It's graphically.
So I have here, what's the question here? What do you think the question? What is your status? What is the status?
How many?
What is the status?
Yeah.
So the status is married, single, widow. I have all this data. What should I do with this data? Now we can find number of singles, number married, number widows. Graphically, I can do bar graph, burrito chart, pie chart. Now remember, with qualitative, you are limited. You have limited computation. I cannot say find the range. Why? Can you find the range?
No, there's no range.
Can I find max?
No.
Can I find min?
No.
Can I find standard deviation? I cannot. You are limited in your computation. So you are limited. So what you're going to do is just total number of singles, total numbers of what? Married,
There's no
total
question
number
here
of
for-
widows.
There's no statistical question here for
You can find statistic question. You can say,
What is the relationship status of group?
you know, like, what's the status of this group?
Yeah.
So the status of this group, we have 20 married, 15 single, and 8 widows. That's it. Yeah, no, not much.
Yeah.
So with numerical data, we can do a lot, but with qualitative data or words, categories, we just limited. Okay. Guided practice here. Okay. Now I want to focus on these two different type of graphs, and tell me what's the difference between this one and this one. Quantitative versus qualitative. Quantitative means numbers, right? And qualitative means what? Words. Okay. Type. Look at this and this one. Tell me the difference. Can you see?
There's a lot more to do with numerical values of quantitative data.
Yeah, I know, but there's something major here, the difference between this one and this one. You see, there's
limit here.
There is what?
Gaps.
Gaps. So when you have, if you're working with words, qualitative, you cannot put them next to each other. You have to have a gaps between them. Why do you have to have a gaps? Because they are text. You have to write the text here. Okay? Clear?
Yes.
And here, you can just, say from 0 to 10, but not 10. 10 to 20, but not 20. So you can put them next to each other, but this one you have to have a gaps. Okay?
Okay, the difference between only the gap.
Misleading gaps. Can you please read? How to identify misleading gaps. Please read.
Graph and statistics are often used to pursue advertisers and others who may accidentally or intentionally present information in
Misleading way. What's mean misleading?
way.
What's mean misleading?
Wrong
Yes.
way.
Yes.
It's, saving.
Seeing a graph doesn't mean you should believe it. Okay. Any graph that distracts the reader from fully understanding what he or she is viewing can be considered misleading. Like the graph has no title, the graph with no labels on axis, like x-axis, y-axis. Graph with no key. I will show you what's mean key. Graph with a vertical axis that does not start with at 0. Graph with different sized graphs, icons, or bars. I will show you. Graph without equal interval on any axis. It's not equal. Graph with a broken or squished axis. I will show you. Take a look at this. Okay, look at this one. Bar chart, right? The first example, favorite colors is, okay. So I took the table and I make what? I make a chart, right? Do you see the chart?
Yes.
Now, can you tell me what's wrong with this chart?
Block is
narrow.
Yeah, narrow, right. So we call bars are not equal what? Widths. That's the problem, right? So he deliberately did this so he can not choose the black. Okay. What else? What else?
There is no space between pink and dark.
Black bar only one width. Okay. Spaces between bars is not equal. It's not equal. See here, they have two gaps, two spaces, one space, one space.
Yeah,
and this one here is no space.
Yeah, the black only one line. And the blue 2 line.
Right. Width. They call width.
Width.
Right. Bar drawn at the wrong height. Black is what? 3. Blue is what? 7. Green is what? 4. Pink is what? 5. 5.5. It's not 6. Orange, 1. So now he's giving you wrong. Right. Is this clear?
Yes.
Another one. Who can tell me?
Same thing for the weight.
Starts at 2.
It's not starting at 0.
Even that.
Frequency axis is not labeled. I don't have label here. What's a label? What is this? Yeah, this is color, but what is this?
Nothing.
You have to write labels, right? Here, do we have a labels? Yes. Yeah, frequency. Here we have color, frequency. Okay. What else?
Blue is not written.
Frequency axis is not.
Yeah, blue is not written.
It's not labeled. That's what we talked about. One of the bars is not labeled. Which bar?
Blue.
The blue one. Space between the numbers on the frequency axis or missed. What does this mean? 6 and 7.
Yeah.
Wow. It's not correct here, you see. He makes it small, you see. 6 and 7. Between 5 and 6, you have one space. 6 and 7, there is no space.
Okay.
And there is no title. What is the title? There is no title here either. So missing title, so we can write this down and say missing the title, missing the title. So we can add that. Also the second one, this one is missing also the title. Okay. Now take a look at this one. Tell me.
doesn't start at 0.
Doesn't start at 0. Good.
Axis not labeled.
Axis is not labeled. This axis, the y-axis. What else?
2021.
Some of the points in the wrong place. He put the points. This point wrong place.
Even
Spacing on the axis. Here, the space is here. Look, he make it so small. So Graphs can be misleading for different reasons. Okay, I will leave this up to you to go through this. You need to print this out and go through those ones. Okay, I'm giving you homework here. Take a look at the misleading graphs here and find out why it's misleading. See, you have this homework. Okay, misleading graphs, practice. So look at this, write the answer. Why? Look at this and this one, write the answer. Look at this, write the answer. This one too. This one and this one. All this is a misleading graphs. Yeah, they can fool you with graphs. So, but if you are graduated from BMU, you will not be fooled. You will be smart.
So identify misleading graphs. Hopefully.